You have spent your entire life so far living at the human scale, where we can often measure dimensions in metres. So if you think about your everyday experiences, we can often only really comprehend things of the size of other humans. However, in A-level physics, we can look at really small things, for example, subatomic particles like protons and neutrons, and smaller things than this, including the electrons and quarks and so on. But also, we can go up to really, really massive things, including things like the size of our sun, which is still a relatively small star compared to some of the big things in our galaxy, as well as black holes, galaxies. The universe itself is enormous. And often, we combine really big things with really small things at the same time. And that's why it's so important to use a prefix. Let's have a look at a question first of all, which says to calculate the distance that light travels in a vacuum in 20 ms, where c, the speed of light, is 3.00 times 10 to the 8 metre second to the minus 1. Now these two things are different, they're only subtly different, but the key thing is where there's a space. There's a space between this m and this s, which means that we have two different units. So we've got metres per second, but here the m is next to the s, and that means this is now a prefix. So this m stands for milli, just like you'd have a millimetre. So this is going to be a millisecond. Now, in order to work out how far the light travels, we can just use the standard equation that says speed equals distance over time, or the velocity is equal to the displacement divided by the time. We can rearrange this to say that s is equal to vt. So if we know how quickly something is moving, in this case it's the speed of light, so that's 3.00 times 10 to the 8, and we're going to multiply that by the time. So when it comes to A-level physics problems, it's always best to work in SI units. This would be using things like metres and seconds, but we've been given our time here in milliseconds, so to convert it into seconds, I'm going to say that's 20 times 10 to the minus 3 seconds. So milli represents 10 to the minus 3. It means 1,000th. So if I work this out, I can just use my calculator to say 3 times 10 to the 8 times by 20 times 10 to the minus 3 gives me an answer of, in this case, it's 6 million. So that would be equal to 6.0 times 10 to the 6 metres. So I've given my answer there to two significant figures, just like the raw data that we've got over here. So that's one way to present the answer. We can give it in standard form. But of course, sometimes we have distances where it might be more appropriate to give the distance in kilometres, where the K stands for kilo, like you have in a kilogram. And these are prefixes that we have to represent large and small quantities. And it's these letters here that represent the common prefixes that you need to know about. So let's go from the really, really small first of all. F stands for femto, and that's something in the order of 10 to the minus 15. We then have P, which stands for pico, and N stands for nano, if you think about things like nanotechnology. And what you'll notice here is that we tend to have a factor of 1,000 between these. So we've got 10 to the minus 15, 10 to the minus 12, 10 to the minus 9, 10 to the minus 6, 10 to the minus 3, and so on. So micro is 10 to the minus 6. Milli is something that you'll be really, really familiar with for millimetres and things. So for example, that's a Latin word milli, whereas micro is from the Greek. This one is 10 to the minus 3. We then have a couple of others. We've got centi, for example, a centimetre, which is 10 to the minus 2. We've got deci, and this is times 10 to the minus 1. And then we start to go bigger. So K, like kilometre, is kilo, and that's 10 to the 3. We then go into the big letters. So for example, M, a capital M, stands for mega, which is 10 to the 6. We then have giga and also tera. And it was only really in the 1960s that these were adopted as part of the SI system. And so these are the things that you're going to become incredibly familiar with as you go through the A-level physics course. It could be that you're given the wavelength of a light in nanometers. You might be given a power in kilowatts or energy in terajoules. So these things here just make it a lot easier when we're using very small and very large numbers. And don't forget, I have a full maths mini course for A-level physics where I've got plenty of worked examples where I go through questions looking at the standard prefixes that you need to be able to use as you go through your A-level physics course. By the way, this is just one of many videos I've made covering all of the maths that you need to understand for A-level physics. It's part of a mini course which includes many more topic videos, multiple worked examples, and also a guide that you can download. You can find all of this over at alevelphysicsonline.com.